Okay, so let's go through these topics to help you get ready for your test then, guys. So we've got to remind ourselves about significant figures. So if you remember the idea behind significant figures, if I take a number like 3.798, then if we was asked to round this to one significant figure, then we find the first non-zero digit. So we find the first non-zero digit, and that becomes our first significant figure, and then we count from there. So this to one significant figure means that I'm going to round to the nearest ones, and the 7/10 is over halfway, so this becomes 4. So that's 4 to one significant figure. If I wanted two significant figures, then I'd find the first non-zero digit again, that'd be my first significant figure, but now I've got a second significant figure to think about. So to two significant figures, I'd be saying, is it going to be 3.7 or is it going to be 3.8? Well, the digit after tells me that it's 5 or more, so it's more than halfway up to the next tenth, so it'll be 3.8 to two significant figures. So let's have a look at the actual question. So this one says round the numbers to one significant figure. So the first significant figure here is the 2, it's the first non-zero digit, and the 2 is in the tens column. So it's asking the question, is the answer going to be 20 or 30? Well, we can see that halfway between there is 25, so 29 is above 25, so it's nearer to 30. So the answer here will be 30. 0.48, the first non-zero digit is the 4, so that's in the tenths column. So it's asking us, is it 0.4 or is it 0.5? And again, if we look halfway, it would be 0.45, and 48 is closer to the 0.5, so it'll be 0.5. 0.0798, the first non-zero digit is the 7, that's in the hundredths column. So the question's asking, is the answer 0.07 or is it 0.08? So is it 0.07 or 0.08? Well, when we look at the next digit on, then we can see that it's 5 or more again. Just the next digit we look at, 5 or more, so it's closer to the 8. So it's going to be 0.08. Numbers bigger than 0, then obviously we need to find the first non-zero digit again. So in this case, so it's a 3. So that's in the 10,000s column. So the question's asking us, is the answer 30,000 or is it 40,000? Well, halfway between those is 35,000. So we have to ask ourselves, where does this go? Well, it's slightly below 35,000, so we're nearer to 30,000. So the answer there will be 30,000. This next question talks about estimating. So a good technique for estimating is to round everything to one significant figure. Not always the case, it really depends on your numbers, because sometimes you can see connections in terms of times tables, factors and multiples. That makes the calculation be a better estimate by looking at numbers in the patterns. But we'll do the technique of round to one significant figure in this case. So 3.76 to one significant figure is 4. 437.8 to one significant figure, well, the first non-zero digit is in the hundreds column, so this is 400 to the nearest hundred, and the 4.12 to the nearest unit is, or the nearest one is 4. So we can see from this question then that we've got 4 divided by 4, so we're left with 400. So our estimate will be 400. This next question is asking us to think about what happens when we work with the nearest measurements. So it's about bounds and error intervals. So we look at this number 1.64. That means there was a kind of a measuring scale going 1.64, 1.63, 1.65, and the actual measurement was given as 1.64. So that means it must be in here somewhere between these two boundaries, and the boundary there is 1.635 and then 1.645. So that tells me then the error interval for this measurement, if we think about error intervals, is going to be it's about a height, so the height is less than 1.645 and greater than or equal to 1.635. 35. So that's our error interval, how small the measurement could be and how big the measurement could be. And then we look at the question. It says what's the maximum height? Well, although it says less than 1.645 is the maximum, it is an interval and it is a boundary. So we do write down 1.645 as the maximum height it could actually be. If we want to be technically accurate, then we should put less than in front of there, but it is a boundary, so it's 1.645 meters. If you try and think that you can't have that number because you'd round up, then the number before that, 1.64999 recurring, well, you'd never be able to measure the difference between that. So it's not that, it's 1.649 recurring. The difference between this number and this number is infinitesimally small. You'd never measure the difference of it, so therefore that's the boundary. Write down the minimum that Lawrence's height could be. Well, the lowest bound was 1.635 meters. So that's what the answer would be for this particular question. The nearest centimetre bit, all that was is to remind you that we're measuring to 2 decimal places, because that column would be how many centimetres you have, this one would be how many 10 centimetres you have, and this one would be how many whole metres you have. So that was just to kind of remind you that we were measuring to that particular place value. Okay, so a square has a length given as 6 metres to the nearest metre. So obviously it's about a square, so it's useful to draw a picture to see what it's talking about. And it's saying what is the smallest possible perimeter of this square. The fact that it's mentioned the nearest, again, implies that we're talking about boundaries. So we were measuring these to the nearest metre, so the scale we was using is going up in whole numbers, whole metres. Therefore the boundaries, which are how small the measurement could have been before it was rounded up, and how big the measurement could have been before it was rounded down. So these are the boundaries. And the question talks about the smallest possible perimeter. So if we want the smallest possible perimeter, then we need to deal with the smallest possible length that the actual square could have had. So the smallest the length could have been was 5.5. So the answer to this question then will be 4 times 5.5, because 4 sides to a square, 4 edges to a square. So we've got 4 5s are 20 and 4 halves are 2, so 22 meters. So that's the smallest the length could have been for the perimeter of this square, by using the idea of boundaries. Again, it's that idea of recognizing that this question talks about the nearest. So it talks about the nearest meter. Okay. So this next question talks about a spinner, 3 equal sections labelled A, B, C. The spinner spun twice. Each time the letter it settles on is recorded. Okay, so because it's got 3 equal sections, then we're probably talking about an equilateral triangle where each of the sections are labelled A, B, and C, and we're spinning that spinner and recording the letter that it lands on. So we've got to draw a tree diagram to represent all the possible outcomes. So the first event for the tree diagram is to spin the spinner, and the possible outcomes, there's 3 of them. So we can have A, B, or C, and that's for the first spin. And then we have a second event where we do a second spin, and if we got A the first time, then of course we could have A again, followed by B, followed by C. And if we got the B the first time, then we could have got A the second, followed by B, followed by C. And if we got C the first time, then we could have got A, followed by B, followed by C. So that's what it means by a tree diagram. It's this idea of showing all the possible outcomes in a kind of a logical way. So what happened? We spun the spinner, and we got a possible outcome of A, or B, or C. Now it's saying that they have equal sections, so that's kind of shouting out at you that when you draw the fully labelled diagram, you need to add in the probabilities. Well, we have to assume that each section is equally likely to appear, So that's going to tell us that we're going to end up with thirds for the probability of getting each of the colours. So, the letters. So the probability of getting A, 1/3, probability of getting B, 1/3, the probability of getting C, 1/3, and we'll go through and then fill in the rest of it. So because the spinner is independent, so whatever happened on the first spin doesn't affect what happens on the second spin, then the probability for each of these is also 1/3. So must fill in the whole diagram because it says draw a fully labelled diagram. So each branch on the tree diagram has a probability of 1/3 of happening. So that shows all the possible outcomes for this spinner, and basically what we're saying is that when we get to here we could have got an A and an A. If we got to here we got an A followed by a B. If we got to here we got an A followed by a C. If we got to here we had a B first, A second, a B followed by a B followed by a C, C first, A second, C first, B second, and C followed by C. So those are all the possible outcomes, and it wants you to show the probabilities. So basically we've got to remember that when we use a tree diagram, if we wanted this particular outcome of A on the first spin followed by A on the second spin, then we'd be picking up 1/3 for the first probability times 1/3 for the second probability. So the actual probability then is 1/9. Now what we notice is every one of these branches is following 1/3 by 1/3, 1/3 by 1/3. So as it happens, every one of these will have the same probability. Doesn't always happen, so don't just assume. You have to think about the probabilities of each branch and multiply them as you come through. So that's the fully labelled tree diagram, all the possible outcomes and the probabilities all labelled out. Then we can look at the last part of the question, and it says what is the probability that when you spin the spinner twice you get the same letter both times? Well, we go back to the possible outcomes from doing both spins, and we want the spinner to give us the same letter both times. So that was A and A, followed B and B, followed C and C. So all these possibilities are meeting the question's criteria. So the probability of A followed by an A, plus the probability of a B followed by a B, plus the probability of a C followed by a C will give us the answer for this particular question. And we saw a minute ago that to work out the probability of each of those outcomes, it was 1/3 times 1/3. So we're going to do a 9th plus a 9th plus a 9th, which gives us a final answer of 3/9, which cancels down to 1/3. So that's how to draw your tree diagram and to think about all the possible outcomes. Following the branches to get to where you want to be, you pick up the probabilities and you times them when you come across. And if you want more than one outcome to get your final answer, then you add each individual outcome because it was that one, or that one, or that one. So either of those would count. So you have to add them all together to get the final answer. Okay, so that's an explanation of tree diagrams and the probability. Okay, so this next question talks about the idea of working with a graph, and we've got to draw a grid, or fill in a grid. So I've got to fill in a, sorry, I'm trying to get the, okay, let's try and see if we can get this, okay, let's turn that gain down a bit. Okay, good, so we can see the graph better now. Okay, so it's asking us to draw a graph of the function y equals -2x plus 3. Well, what we need to remember about these straight line graphs, guys, is that it's about coordinates, and we need to remember that our coordinates are an x number followed by a y number when the graph talks about functions in terms of y and x. And it's telling us in this case basically to get the y coordinate times the x value by -2, then add 3. So that's basically what it's telling us. So we look at the graph scale, and it's got some numbers across the x-axis here. So we can use those to create the coordinates. So if we choose the simplest one of all, so 0. So if we do -2 times 0 is 0, plus 3 is 3. And then if we choose 1, -2 times 1 is -2, plus 3 is +1. If we do 2, -2 times 2 is -4. -4 plus 3 is -1. Okay, so when we're drawing graphs of the functions y equals so many x's plus something, or we swapped it about to be y equals so many x's plus something, then it's going to be a straight line because x has only got a power of 1, and therefore we only need 3 coordinates, and we basically make sure that our 3 coordinates line up, and then we draw the graph all the way across the graph paper, and obviously we should label it to show that we know what we're doing. So y equals -2x plus 3, and that's how that question can be answered. It says work out the equation of the straight line already drawn on the grid above. Okay, I rushed to get the homework sheet out, guys. I forgot to draw that line on. So let's just draw a line on, and we can hopefully work out the equation of it, just to show you how you would do that if you'd have been given the question. So okay, so we've got an equation, a line drawn on, and we've been asked to work out the equation of that straight line. So all straight lines have the format of y equals mx plus c in GCSE mathematics, and it's just the way it works. Y and x obviously could be different variables. If the graph was about temperature and pressure, then it would be t equals something to do with p plus some number. Okay, so the graph would maybe something like that, and we'd have been using t and p rather than y and x. Okay, so we've got to think about how do we work out the equation of this line. Okay, so we need to recognise a standard form then, so y equals mx plus c. Talking about a straight line, technique, choose 2 coordinates to work out the change in the y coordinates, which some people remember as a rise, how far up you go, or how far down you go, negative of course if you go down, and a run, how far along the x-axis you've gone. So the gradient m is defined as the rise over the run. So m is the gradient of the line, how steep it is. And c is the intercept point on the y-axis when x is 0. So the intercept point is equal to the c value. So that's the kind of facts that we need to learn and practice when calculating the equation of a straight line. Okay, so we're going to choose 2 points on this graph then, so I'm going to choose that one and that one, purely because I can read the coordinates off reasonably easy. And we draw our right-angled triangle to allow us to work with our rise and run. So in this case then we can see that the rise was going from -2 up to 1, so that's 1, 2, 3. So we had a rise of 3, or a change in the y coordinates of 3, and across the x coordinates here we went from 0 across to 2, so we had a run of 2. So in this case the change in the x coordinates was 2, so the run was 2, and the change in the y coordinates was 3, so the rise was 3. So when the question says work out the equation of the line, then we follow the format y equals mx plus c. We work out the gradient by doing the rise number over the run number, and in this case we found that the rise was 3 and the run was 2, so our gradient is 3 halves, so 3 over 2. So our equation is going to become 3 over 2x, and our c number is where the line crossed the y-axis, which in this case is -2, so that's going to mean it's going to be take away 2. Now we should check that this works, because the whole point is that any coordinate we choose, so for example if I choose this coordinate here, then we can see that we're expecting the answer when x is 4, y should be 4. So let's just see whether that works. So we're going to check what happens when x is 4. So we're doing 3 over 2 times 4, and then we're going to take away 2. Okay, 3 over 2 is 1.5. 1.5 times 4 is 6. 6 take away 2 is 4. And we saw on the graph that the y number was 4, so our check worked. So the check worked to show that the y number was going to be 4. Okay, so that's a reminder about how to find the equation of a straight line when you're given a line drawn on a graph, and how to draw a linear graph if you need to. Okay, so the next question says work out the gradient of a straight line that goes through the coordinates here given. So words, no picture, so it's useful to draw a picture to see what's going on. So 3, 8 could be given as there, and 7, 20 could be given as there. So that's going to be 3, that's going to be 7, and that's going to be 8, and that's going to be 20. And we're told there's a straight line between them. So we know that we've got to work out the gradient of that line. Well, the formula for the gradient is given as the rise over the run, which is literally the change in the y coordinates. So in other words, the difference between them over the change in the x coordinates. Now, in some textbooks and other sources of material, you'll see a nice little formula that says y2 take away y1 over x2 take away x1, and all that is saying is you do the two y coordinates take away from each other divided by the two x coordinates taken away from each other, but the takeaways are done in the same order. So y2 and x2 are the second coordinate, and y1 and x1 are the first coordinate. So if we join this up, we can see that the change in the x coordinates is 4, so 7 take away 3 was 4, so that's our run number. And the change in the y coordinates was 12. 20 take away 8 is 12, so our rise equals 12. So to work out the gradient then, we take our rise number 12 and we divide by our run number of 4, so the gradient in this case is 3. So although the question said y equals on the answer line, I'm not sure why I left that there. It should just say the gradient, so the gradient answer is 3. We're not asking to work out the equation of the line, we're just asking to work out the gradient, so I didn't need the y equals. Apologies for that. Okay, so that's a reminder about how you can calculate the gradient of a straight line if you're given coordinates. Okay, so the practice questions go on to looking at solving simultaneous equations now. So we've got to think about the technique for this. The technique that seems to work best is when we have the same number in front of one of the variables. We haven't got that in this case. We've got 3 in front of that x, a 5 in front of that x, we've got a 2 in front of that y, and although we don't write it, there's a 1 in front of that y. So it would seem sensible to double this equation, because that will then give us the same number in front of the y there. The two have different operations, but it'll have the same number, the same coefficient. If I double 5x plus y equals 25, then we get 10x plus 2y equals 50. Now, we've now got two equations where there is a 2y in. Now, to solve simultaneous equations, we need that to happen because we need to cancel one of the letters out so that we can actually solve just one equation. We need to remember that if we had x plus y equals 10, then there's an infinite number of solutions. So that doesn't help us. So we need two equations to work with this kind of problem so that we can eliminate one of the letters to fix the value of 1, and then we can use that fixed value of one letter to then fix the value of the second letter. So we've got two equations then. So let's have a look what they look like together. So 3x take away 2y equals 2, and then we've got 10x plus 2y equals 50. Now when we have the situation of the same number in front of one of the letters, then we look at whether we're going to add or subtract the equations that we've created or used so that we can cancel out. Now I'm going to add in this case because negative 2 plus positive 2 will make 0, so the y's will disappear. Negative 2 plus positive 2 equals 0, so that means the y's will go. So 3x plus 10x is 13x, they've gone to nothing, and 2 plus 50 is 52. So we have 13x is worth 52. I want one of those x's, so we divide by 13. 13 divided by 13 is 1, so we're left with 1x, and 52 divided by 13 is 4. So we think the x value is 4, so we put this value, in other words we substitute. So we put this value into, well, it doesn't matter, I could do it in that equation, I could do it in that equation, I could do it in that equation. Because I've got a fixed value of x, then I can always find the y value, but we'll keep it simple. I'll choose the one that says 5x plus y equals 25. So we're doing this to find the y value, remember. So we know what the x value is, or we think we know it is, so we think it's 4. So 25, 5 4s are 20, take away 20 from both sides, and that tells us the y value is 5. So we think that the x value is 4 and the y value is 5. With this topic it's really important that you check in the other equation. Simultaneous means that the two values you find should work for both equations at the same time. If they don't, then you've done something wrong in your adding or subtracting. So we check in the other equation. So in this case we use the 5x plus y equals 25 to find the y value, so we must check it in the other one that we didn't use for that purpose. So we're hoping that 3x take away 2y will give us an answer of 2. So 3 lots of 4, take away 2 lots of 5, 3 lots of 4 is 12, 2 lots of 5 is 10, and 12 take away 10 is 2. So our check worked. So on the answer line then we can say that x is worth 4 and y is worth 5. So that's a reminder of how you can calculate missing values for x and y, or whatever letters they give you in the simultaneous equations. The key steps: make one of the letters have the same number in front of it by manipulating the equations if needs be. If the number in front is already there, then you're simply going to go to the second step, which is you either add or subtract the equations to cancel that letter out, the term with the same number in front. If the operations, basically the clue is, if the operations are different, then you always add. If the operations are the same, so if that was a minus and a minus, you'd still do a takeaway, and if that was a plus and a plus, you'd still do a takeaway. So that kind of technique works. Okay, so the next question talks about working with the mean, average, mode average, and the range. So it's asking us to find the 7 numbers. Well, we've got to look through and think what information do we actually have from all of this. So the mode average is 6. Well, that means that 6 must occur at least twice, and all the other numbers just once, or it could occur 3 times and then the other numbers once or twice. So we know that the mode means that the 6 has got to occur more times than the other number. So that's one clue. A range of 9 means that from the max value we're going to choose, take away the minimum value, then that must equal 9. And the mean average of 7 is telling us that we did a total of the 7 numbers, divide by 7, and that gave us an answer of 7. So we can go backwards with this to find out what the total was. So the total of the 7 numbers must equal 7 times 7, so 49. We know the mode has to be 6, and we know the range has to be 9. So it seems logical to try 6 or 6. On a range of 9, so I might try 3 at the beginning and 12 at the end, because 12 take away 3 would be 9. I can see what total I've got so far. I know that I'm trying to build up to 49, so let's have a look what we've got so far. So we've got 9, 15, 25, 27, so I need 22 more. I need 3 more numbers, so I need 22 from 3 more numbers. So if I went for 22 from 3 more numbers, 22, so if I choose a 7, that leaves me with 15, If I chose 10, that would leave me with 5. Okay, so let's have a look and see if that works then. This might not be the only answer, because obviously I could have had 11 and 4. That would still give me 15 in the middle there. So does this add up to 49? 3 plus 5 is 8, 14, 20, 27, 37, 47, 49. Divide that by 7 is 7, so the mean works. The mode is 6 because it occurs the most, and the range is 9. So this is one possible answer. There are lots of others. It's basically, do your 7 numbers add up to 49? Does the mode give you 6? In other words, are there more 6s than any other number? And when you take your biggest number and subtract your lowest number, do you get an answer of 9? So there are lots of answers for that particular question. What is the median average for the 7 numbers? Well, this will vary depending on what you had in your answer. But the median is the number in the middle, so when they're in size order. So this list is already in size order, so the median is going to be the middle. So in this case, it's going to be 6. You might have a different answer here, though. It really depends on what numbers you chose here to give you the conditions asked for. Okay. So the next question talks about working with an isosceles triangle. Again, it's got loads of words but no kind of picture, so let's sketch a picture to see what we're doing. So we should remember that an isosceles triangle has the property of 2 edges the same length, normally shown by putting dashes through. And it's told us this particular isosceles triangle has a base length of 8 centimeters, and it has a perimeter of 18 centimeters. So that means all the edges must add up to 18. These two have to be the same though, so it would have to be 5 and 5, and we'll put the usual caveat next to diagrams, not to scale. Okay, so that gives us an idea of what this isosceles triangle looks like. The question asks for the area. It's asking for an area of a triangle, so again, the advice always is to write down the formula for calculating the area of a triangle if it's about that topic. So a half times the base length times the perpendicular height. And the picture we tend to have in our mind about triangles is the base length and the perpendicular height is measured. So that gives us a clue again, because we've already got a base length for this triangle. We just need a vertical height. Well, because it's isosceles, then if we drop a line of symmetry down, then the height of this triangle is measured at right angles to this. And what we can see is we need this height, but we do recognise that we have a right angle triangle in part of this picture. And this length here, because the line of symmetry has cut the isosceles triangle in half, is 4 centimeters. Therefore, we can use Pythagoras, because we have a right angle triangle where this is 4, this is 5, and we've been asked to work out the vertical height of the triangle H. And we need to remember that Pythagoras says take the square length, the lengths of the short sides, square them, add them together, and it equals the length of the long side squared. So we have to remember from our standard triangle for Pythagoras that the 2 short sides are labelled A and B, and the long side is labelled C, the hypotenuse is C. So in this case then, we have 4 squared plus h squared equals 5 squared. So 16 plus h squared equals 25. So h squared must equal 25, take away 16. So h squared is worth 9. And what we need to remember with Pythagoras is that when we want to get the actual length, we know the square of it, so we do the opposite of squaring to get the actual length it started from. So h is going to be the square root of 9, which in this case will be 3 centimeters. So now we know what the height of the triangle is. We can go to the formula for the area of a triangle. So the area of the triangle then was a half times the base length. Well, the base length in this triangle was 8. We've worked out the vertical height was 3. And if we do a half of 8, that's 4, times by 3 is 12. The question already told us the units, but you should really be in the habit of writing the units out so that you always don't miss them. So this question was helped by drawing a picture and thinking about what properties we needed. The properties we needed came from the formula for the area of the triangle. That then allowed us to think, well, we know the base length, but we need the vertical height. Then we recognise that an isosceles triangle can be split in half through a line of symmetry. And then we recognise we've got a right angle triangle, so Pythagoras shouted out, please use me, I've got 2 side lengths given, and I need to find a third. So Pythagoras was useful there. Okay, so that's that question. This next question talks about completing the table of values for a quadratic function. Remember, this is a quadratic because of the power 2. So the graph of this we'd expect to have a U shape because it's a quadratic. Power 2 graph. And we've got to fill in the values. So we need to remember that we substitute the values in brackets. So we've got -1 being squared, take away 4 lots of -1, take away 2. Well, -1 squared means -1 times -1, which gives us +1. 4 lots of -1 is -4, but we've got a minus sign in front of it, so it becomes a plus, we get bigger. So that becomes 1 plus 4, and then we're taking away 2, and that gives us an answer of 3. Okay, so when we use 2, we end up doing 2 squared, take away 4 lots of 2, take away 2. Well, 2 squared is 4, 4 lots of 2 is 8, it's a minus because that's positive, so it's just -8, and then take away 2 more. 4 take away 8 is -4, take away 2 is -6. And then when we do it for 3, well, we can do this in several ways. Once we recognise this is about a quadratic graph, we can see that all quadratic graphs have a U shape, and all U's have this line of symmetry. So therefore, if we know the values coming in this direction, then they have to repeat in that direction. So if we notice there's a pattern going on here, because this is going across in 1, so the x values are changing by 1 all the time, then the pattern should be 3, -2, -5, -6, and it should then repeat itself, -5, -2, 3. So it's like a symmetry pattern. So we know the answer here should be -5. We check it, of course. So 3 squared, take away 4 lots of 3, take away 2, following the rule that was given. 3 squared is 9, 4 threes is 12, take away 2, 9 take away 12, -3, take away 2 more, -5. Okay, so using the ideas of substitution, using the values of x that they're given us in the table, we can fill in the missing values for this function. The question then says go on and draw it. So we're going to need to use these values to create coordinates. So for example, -1, 3 gives us the coordinate of -1, 3, because coordinates always follow an x number and a y number. So we need to plot those. So the first coordinate then was -1, +3. The next coordinate was 0, -2. The next coordinate was 1, -5. The next coordinate was 2, -6. The next coordinate was 3, -5. Next coordinate was 4, -2. And the next coordinate was 5 and 3. Okay, so those are our coordinates. And again, what we need to remember about graph questions of this type, when we're drawing this is a smooth curve with a U shape. So we have to try our best by ghosting maybe what the curve should look like and then drawing it. So try and ghost it before you put your pen down, and then literally just try and follow best curve you can going through the crosses, and then because it's a U shape we kind of try and draw the symmetry the other way going through the crosses. Okay, so that will get you the mark in the exam. It's not perfect, but it is showing that you've understood it's a U shape. Okay, so just to finish this question off then, the question went on after drawing the graph to ask you to work out the coordinates of the minimum point. Well, the minimum point of any quadratic graph is always where the curve either bottoms out for the minimum, or if it was to top out, it would be the maximum. And basically we read off the coordinate. So in this particular case, the graph bottomed out at 2, -6. So the coordinate of the minimum point was 2, -6. The question then said estimate the roots of the graph. Well, the roots of the graph is when the function equals 0. So when x squared take away 4x take away 2 equals 0, that produces the roots and basically we look where the graph equals 0. So the graph has values by following it down. Here it had a value of 3, then it had a value of 1, here it has a value of 0, so therefore the root happens at this point here. And if we follow the graph around, we can see that there's a second root, which is when the graph also equals 0. And then we just read off the x-coordinates, because the graph is asking us to find the roots, and the roots are the x-coordinates that cause the equation to give an answer of 0. On my graph, I've got an answer of x is negative 0.6 and positive 4.5, but freehand drawing means that you could be out, or I could be out and you could be accurate. So it's plus or minus 0.2 on both those numbers, guys. Okay, so that's the roots of the equation and how to find the minimum point.